A complete computer guide.
Hi, welcome you all in my channel. As you know, I am Dhananjay. Today I have come with 19th video of QBASIC series. Today we will read the solved examples of all the number system conversion, like binary to decimal, decimal to binary, etc. Viewers, if you have not seen my previous videos, then go to YouTube and search there KD Production, that's my channel name. After opening that channel you can see my all updated videos, or just go to playlist and there you will see computer guide playlist. On that playlist I have put all the videos of QBASIC from starting. If you have any confusion in any topic, then you can watch there. So, first watch those videos to clear understand, then come here and watch it. Viewers, if you like my videos, or that is useful for you to learn, or that provide you some important knowledge, then please like, share, and comment there, and also don't forget to subscribe my channel. First question is program to convert binary number into decimal. Here, program is to convert binary number into decimal. First of all, we will write CLS. After that let A is equal to 1. Then B is equal to 0. Now, input space double quotation, then we will write the message. Here the message is to enter any binary number because we are going to convert binary to decimal. So after ending of double quotation, we will write the variable in which binary number is assigned. Now, while C is not equal to 0, it the condition to check, and here less than and greater than sign is used to indication of not equal to. Then R is equal to C mod 10. After that B is equal to B plus A into R. Now, A is equal to A multiply 2. Then C is equal to C integer division 10. After that wend to close the loop. And now finally we have to display the decimal number in print statement. And at last end the program. Now, explanation of program, we must know about it that, to convert binary into decimal we need to multiply the each digit of binary number with the power of base of binary number. 1. CLS clears the screen to provide a clean output. 2. Let A is equal to 1 and let B is equal to 0 initializes two variables, A and B, is used to keep track of the position value, powers of 2, starting with 1, and B is used to accumulate the decimal equivalent of the binary number. 3. Input enter any binary number. C asks the user to input a binary number and stores it in the variable C. 4. While C not equal to 0, starts a loop that continues as long as the value of C is not equal to 0. This loop will process each digit of the binary number from right to left. 5. R is equal to C mod 10, calculates the rightmost digit, remainder, of C using the modulo operator, mod. This digit will be either 0 or 1. 6. B is equal to B plus, A into R calculates the decimal equivalent of the current binary digit, R, by multiplying it with the corresponding position value, A, and adds it to the accumulated decimal value, B. 7. A is equal to A into 2 updates the position value, A, by multiplying it by 2 to prepare for the next binary digit's position. 8. C is equal to C integer division 10, removes the rightmost digit from C by integer division, backslash operator, effectively shifting to the next digit of the binary number. 9. Wend, the wend statement marks the end of the while loop. and the program goes back to the while statement to continue processing the remaining binary digits. 10. Print decimal equivalent of given number is B. Once the loop finishes processing all binary digits, it prints the calculated decimal equivalent of the entered binary number. 11. End ends the program. This program iterates through each digit of the binary number, calculates the contribution of each digit to the decimal value, and accumulates the result in the B variable. Finally, it displays the decimal equivalent of the binary number. Question 2 is program to convert decimal into binary number. Here is the conversion of decimal into binary number system with explanation. Rem decimal to binary conversion in QBASIC. CLS. Input enter a decimal number, decimal. Binary dollar is equal to. If decimal is equal to 0, then binary dollar is equal to 0. Else, while decimal is greater than 0, remainder is equal to decimal mod 2. Binary dollar is equal to ltrim dollar, str dollar, remainder plus binary dollar. Decimal is equal to int, decimal divided by 2. When. End if. Print, the binary representation is binary dollar. End. Explanation. CLS clears the screen to provide a clean output. Input enter a decimal number, decimal, prompts the user to enter a decimal number and stores it in the decimal variable. Binary dollar is equal to initializes an MP string binary dollar to store the binary representation of the decimal number. If decimal is equal to 0, then else. And if, this is a conditional statement. If the input decimal number is 0, it directly assigns the binary representation as 0. Otherwise, it enters a loop to calculate the binary representation. While decimal 0. When, this is a loop that continues as long as decimal is greater than 0. Remainder is equal to decimal mod 2, calculates the remainder when dividing decimal by 2. This remainder will be either 0 or 1, representing the least significant bit of the binary representation. Binary dollar is equal to ltrim dollar, str dollar, remainder plus binary dollar, converts the remainder to a string, trims any leading spaces, and then appends it to the beginning of the binary dollar string. This is done to build the binary representation from right to left. Decimal is equal to int, decimal to updates the decimal variable by performing integer division by 2, effectively removing the least significant bit. Finally, it prints the binary representation using print. The binary representation is binary dollar. This basic program converts the input decimal number into binary by repeatedly dividing the decimal number by 2 and recording the remainders until the decimal number becomes 0. The binary representation is built in reverse order, and the result is displayed on the screen. Question 3 is program to convert octal into decimal. If you have understood previous program, then it is easy for you to understand the conversion of octal into decimal. Hexadecimal into decimal. This program is same as the previous conversion of binary into decimal, only you have to change the base value, that is 2 in binary to decimal case, 8 in octal to decimal case, 16 in hexadecimal to decimal case. You can learn this program serially. It is used to convert a number from a given base to its decimal equivalent. Here's a step-by-step explanation of what the code does. Let A is equal to 1 and let B is equal to 0. These lines initialized to variables a and b is used to keep track of the position value in the original base, starting with 1, and b is used to accumulate the decimal equivalent. Input enter number to conversion, c. This line prompts the user to enter the number they want to convert, and the input is stored in the variable c. Input enter base, d. This line prompts the user to enter the base of the number, and the input is stored in the variable d. The while loop, this loop will continue until c becomes 0, which means it processes each digit of the input number from right to left. R is equal to c mod 10. This line calculates the remainder when c is divided by 10, effectively extracting the rightmost digit of c, and stores it in the variable r. B is equal to b plus a asterisk r. This line updates the decimal equivalent b by adding the product of the position value a and the extracted digit r. C a is equal to a asterisk d. This line updates the position value a by multiplying it by the base d. This step is crucial for maintaining the correct positional value for the next digit. C is equal to c backslash 10. This line removes the rightmost digit from c by integer division, integer part of the division result, effectively moving to the next digit. When this keyword indicates the end of the while loop. Print decimal equivalent of given number is b. This line prints the decimal equivalent of the given number, which has been accumulated in the variable b. And this is typically used to indicate the end of the program. Overall, this code takes an input number in a specific base and converts it to its decimal equivalent by repeatedly extracting digits from right to left, multiplying them by the appropriate positional values, and summing them up in the variable b. The result is then printed out. Question 4th is program to convert decimal into octal, decimal into hexadecimal. In this case also we cannot convert value of hexadecimal like A, B, C, D, E, F. This program is also same like previous program, only we have to insert the base dot what is the base, according to that it converts decimal into octal, decimal into hexadecimal. I am leaving the explanation part of this program for you. If any confusion in any program then you can comment, I will solve your problem. In this video this much only, in next video I will bring something new. So, keep watching my channel and thank you for watching my videos.